Alright, so if we go over section 3.6, we're going to look at the graphs of some other trig functions. So section 4.5, which we went over last Thursday and Friday, was on the graphs of sine and cosine. So today we're going to look at our graph of tangent and our graph of our inverse functions, cosecant, secant, and cotangent. So if I start with our graph of tangent, the graph of tangent looks kind of like a cubic function, and that it starts down and goes up, crossing through 0, and the period of tangent goes from negative pi over 2 to pi over 2. Alright, and then just like before, we had to find our endpoints of our period whenever we made adjustments to the graph. And so to find our endpoints of tangent, if we're looking at the function y equals a tangent of bx minus c, we take that bx minus c and we set it equal to negative pi over 2 and to pi over 2. And that will give you your endpoints. Okay, so if we look at the graph y equals tangent of x over 2 and we want to graph that, the first thing that we have to find is our endpoints. And so to find our endpoints, we take that x over 2 and we set it equal to negative pi over 2 and to positive pi over 2. Okay, and then we need to solve them for x, so we solve them by multiplying each side by 2. And so we end up with x equals negative pi to be our furthest point to the left, and x equals pi to be our furthest point to the right. Alright, so then I go ahead and draw my x and y axis. I know that my furthest point to the right is going to be pi, and that my furthest point to the left is going to be negative pi. And I know that my tangent graph crosses at 0. So I know that these points that I just found, my endpoints, are going to be my asymptotes. And so knowing that, I know that tangent starts down and ends up. So the first period of my tangent graph is going to go from negative pi to pi. Okay, I do the same thing with tangent is pi over 4. In order to find your period, you set the pi over 4 equal to negative pi over 2 and equal to pi over 2. In this case, I guess we really don't have an x. I think this is supposed to be x over 4. I'm going to change it to an x, because you have to have an x in order to be able to solve. Duh. I'm going to multiply by 4. Multiply by 4. So then I get x equals, this will cross cancel to be 2, so negative 2 pi. And the second one cross cancels to be positive 2 pi. So I get periods from negative 2 pi to 2 pi. So if I start with my x and y axis, I know that my furthest point to the right is going to be 2 pi, and my furthest point to the left is going to be negative 2 pi, and those will make up my asymptotes of my graph. I also know that tangent always crosses through 0, and starts down, ends up. So my first period of tangent would look like that. So y equals -3 tangent of 2x. Before, we had to pay attention to this -3 because it told us how high up on our graph we go, but on a tangent graph, you don't have to pay attention to it because it doesn't affect the graph. So we're just looking at this 2x, and so to find my endpoints, I set it equal to -pi/2 and pi/2. To solve, I divide by 2. So this actually ends up being x equals -pi/4. If I divide by 2, divide by 2, this ends up being x equals pi/4. Then I know my furthest point to the right is positive pi/4. Furthest point to the left is -pi/4. We cross through 0. These become my asymptotes. So I start down and end up. Alright, so those are tangent graphs. Cotangent graphs look very similar, except because they're inverses, they start up and end down. So they're like negative tangent graphs. So the graph of cotangent has a period that goes from 0 to pi, so it's shifted over to the right by pi/2, and then it starts up and ends down. So if we look at graphing a cotangent function, we need to find our endpoints. And like I said, our endpoints are different on cotangent than they are on tangent because the graph is shifted to the right by pi/2. So if I use x/3, the part that's inside my cotangent graph, my first endpoint, my first vertical endpoint was 0. Okay, then my second vertical endpoint was pi. So it always goes from 0 to pi. So then if I solve those to find my endpoints by multiplying by 3, 0 times 3 is just 0, so I know my first endpoint is going to be 0. Pi times 3 gives me 3 pi, so I know my second endpoint is going to be 3 pi. So I know that my first endpoint is 0, my second endpoint is 3 pi. And these form my vertical asymptotes. I then also know that my graph crosses at 0, and for a cotangent graph, we start up and end down. So my graph would look something like that. Alright, if we do another cotangent graph, we're given x/4, cotangent of x/4, so I know x/4 has to equal 0, and x/4 has to equal pi to form my endpoints. So then if I multiply by 4, I get x equals 0 for my first endpoint, and x equals 4 pi for my second endpoint. So 0 and 4 pi form my asymptotes. I know that my graph crosses halfway in between and starts up and goes down. Alright, The other two graphs we're going to look at are our cosecant graphs and our secant graphs. And those are going to be our hardest graphs. So I know that this looks really complicated, but I tried to make it as simple as I could. So you have vertical asymptotes of your cosecant graph at every pi. So pi, 2 pi, 3 pi, etc. Everywhere you're at pi, you're going to have those vertical asymptotes. This red graph is actually your sine curve. And so since cosecant is your inverse of sine, your cosecant graph bounces off of your sine curve at every maximum and minimum. And there's a vertical asymptote whenever sine is equal to 0. So at all of those zeros is going to be vertical asymptotes, which is why at every pi there's vertical asymptotes. So when my sine curve is at a maximum of pi over 2, my cosecant graph bounces off of that and forms like a little parabola going up. And then when it's at a minimum, it forms a parabola going down, and it just keeps that cycle. So your cosecant graph is the one that's in blue. Alright, and then the second graph we're going to look at is our secant graph, which looks equally as complicated because it's the inverse of cosine. And so everywhere that your cosine graph is equal to 0, which is at every odd pi over 2, so pi over 2, 3 pi over 2, 5 pi over 2, etc., you have vertical asymptotes. So every odd pi over 2, that's where you're going to see those. And then everywhere, at every min and max of your cosine graph is where your secant graph forms, and it bounces off of those to form opposite parabolas, so one going up and then one going down. Okay, so I'm going to graph y equals 2 cosecant of x plus pi over 4. I know that cosecant is the inverse of sine. So what I'm actually going to do is I'm going to graph 2 sine of x plus pi over 4, because that then tells me where my cosecant graph is going to be. And so if I go to graph 2 sine of x plus pi over 4, I know that to find my endpoints, I have to set x plus pi over 4 equal to 0, and x plus pi over 4 equal to 2 pi. I also know that my amplitude, because of this 2, is going to go between -2 and 2 on my y-axis. So if I go ahead and solve these by subtracting pi over 4, I get x equals 7 pi over 4, and x equals negative pi over 4. Alright, so now my furthest point to the left is negative pi over 4. To the right, it's going to be 7 pi over 4. And I know that I have 5 points that I always make on a sine graph. Oh, and then my amplitude went from 2 to -2. I also knew that. Alright, so if I graph my sine graph first, sine always starts at 0. So we're starting back at negative pi over 4 over 0. And then sine goes up and then down. Okay, so my red graph makes up one cycle of sine. But I know that my cosecant graph is the inverse of that. And so everywhere where my sine graph crosses 0, or crosses your x-axis, I know that I have vertical asymptotes. And then I also know that my cosine graph then bounces off of my minimums and maximums and goes in opposite directions. So it's going to go up on the bottom and down on the bottom. So my cosecant graph is the one in green. I do the same thing with another cosecant graph, I know that cosecant is the inverse of sine, so what I'm really finding is 2 sine of x plus pi over 2, so that I can graph that. And so I know that to find my endpoints, I'm taking x plus pi over 2 and I'm setting it equal to 0, and equal to 2 pi. And then I also know that my amplitude goes from -2 to 2. So if I subtract pi over 2 to solve for x, then I get x equals negative pi over 2 and x equals 3 pi over 2 as my endpoints. So, negative pi over 2, 0, 1 pi over 2, pi, 3 pi over 2. Okay, and I know that I go from positive 2 down to negative 2. Alright, and your sine graph always starts at 0 and then goes up. So I know that my sine graph is what's in red. I also know that I have vertical asymptotes everywhere that sine crosses the x-axis. So at all of those zeros, I have vertical asymptotes. So then my cosecant graph bounces off of my minimum, so that one will go down, and this one goes up. Alright, let's do one secant graph, and then we'll call it good. So secant of 2x. So, since I don't have a number in front of my secant, I know that my amplitude is going to go from -1 to 1. And then I know that I need to solve 2x equals 0 and 2x equals 2 pi to find my endpoint. 0 and 2 pi are always your endpoints for every graph except for tangent. So I divide by 2. X equals 0 and divide by 2. X equals pi. Okay, once I have that information, then I can graph my cosine graph. So I know my first point, my y-axis is here, x-axis is here. I'm going from 0 to pi, and I have 5 points in between. And I also know that my amplitude is 1 to -1. Alright, and cosine always starts up and then goes down. So I know my cosine graph is going to start up and then go down and then back up. So my cosine graph forms what's in red. I also know that everywhere that my cosine graph crosses the x-axis, I have vertical asymptotes. So then if I identify my maximums and my minimums, I know that my secant graph is going to bounce off of those max and mins and form parabolas. Okay, so that's your secant graph. Page 336 has all of your trig parent functions, so if you forget what they look like, you can look on page 336. The other type of graph we didn't go over and we're not going to go over is what's called a damped graph, and that just means that you have 2 functions put together, like x squared times sine of x. And I want you to do those all on a graphing calculator. So you'll just plug those into your graphing calculator to graph them, and then you'll just sketch the graph You'll have about 6 of those to do, I think. And so your assignment's going to be page 337, 15 through 28. Then you'll skip all the way up to 73 through 76 and 81 through 84. We're going to work on this today and tomorrow.